You can embed Python directly into LaTeX documents, and at build time have the Python code executed. Any matplotlib figures that are generated brought back into LaTeX with perfect font integration, and he's going to demonstrate that system for us.
So after hearing the IPython presentation a few minutes ago, today is shaping up to be a good day for tech users, and I hope that I can make it even better. This project actually goes back to the beginning of last summer. I've been using Python for about 2 years now, primarily in classes that I teach. I've been using it a little bit in a mechanics class, and then also to teach numerical methods in a mathematical physics class. But at the beginning of last summer, I decided that I really wanted a way to get to Python from within LaTeX, so I started developing this system. And looking back, I hadn't ever done any real macro programming with tech. I'd written a lot, but never gotten into the gory details. Also hadn't done any general purpose Python programming, so it's been a little bit of an adventure, but overall I think the end result is pretty successful. So what I'm trying to address is the way that the workflow with a tech document can often get to be a little bit bothersome. If you have a simple document, you can do something like this, send your document through LaTeX, get your PDF or other output, and go on from there. Problem with scientific documents and presentations is that you often find yourself hopping out of the document. You have to find some code that maybe makes a figure, does a calculation, run that through its own software, get your result, come back again. And this can really disrupt the workflow. If you're editing along, you suddenly realize, oh, that figure has the wrong color. Go find the code that created that figure, run the code. You can just sort of lose your place. So the idea with PythonTeX is that code and document, Python code and the document, all in a single file that's processed by LaTeX in a script, get a PDF out at the end. I'm not going to get into the technical details of how this works, but here's the basic idea. Start off with your document and the code again in the document, run that through LaTeX. You'll get a PDF or whatever other output you're going for. No Python content in at that point, and the PythonTeX package extracts the Python code from your document, saves it into a separate external file. That external file is then processed by a PythonTeX script, puts out results in a format that are suitable for access back into LaTeX, and then final compile cycle through LaTeX, document goes in, bring those results in, and get your completed PDF document. I want to point out at this point that everything you're going to see from here on out was created with a single document. I did have to actually use an external program to draw those last few figures, but everything from here on I created without ever leaving my tech editor, and this is all using the Beamer class. This idea of putting non-LaTeX code into LaTeX isn't original with me. It goes back at least to SWeave with the R statistical environment, 2002. In terms of Python, the earliest example I'm aware of is python.sty. There's been SageTeX since then, also SympyTeX, which is basically SageTeX but for Python with slightly reduced functionality. But all of these have some real limitations for general Python use. The python.sty is good for executing small code snippets, but if you want to do some serious large calculation, it's just really not going to work very well for you. SageTeX, customized for Sage, and then of course SympyTeX, being based on SageTeX, inherits a lot of that, so there's some limitations there. So what I'm going to do is give you a summary of what I see as the key features of PythonTeX, and then move on from there to show you some examples of what's possible. Everything that Python generates is always saved. What this means is that if you're working with a document, you can change anything in the document that you want to and recompile without ever going to the Python side of things, as long as you don't change any of the Python code. So it makes it a lot easier from the editing perspective. There are user-defined sessions in SageTeX and SympyTeX. All the code that you put in the document has to run within a single session. I'm allowing user-defined sessions, so if you have some slow code, put it in its own session. Sessions run in parallel with multiprocessing, so you can get some pretty good speed up there, and everything's hashed, so you only execute code when you actually really have to. There's easy access to standard out and standard error. I'll show some examples of that a little bit later, but I see this as a very key feature for general Python access from within a LaTeX document. Error messages are synchronized with the document. This is also very important because the LaTeX document has one line numbering. The code that's actually executed has a separate line numbering. We need a way to match those up if we're going to be able to, from within the tech editor, actually figure out where the error occurred, debug, and keep moving. Finally, I'm providing general syntax highlighting with pigments, and I'm providing highlighting for any language, not just Python. So if you do want to use this just for highlighting purposes, it's also available for that. And there is Unicode support if you do need to use international characters, for instance, in your comments and so forth. What I'm going to do now is show you a little bit of what the actual code looks like. There are 4 environments and 4 commands that PythonTeX gives you. The code environment executes whatever it contains. So in this case, I'm creating a variable. I'm also printing some content, printing a string. And then the output here that I'm showing at the bottom, the standard out from that last environment is automatically brought in. There's also a block environment. This typesets the code that you put in, syntax highlighting again with pigments, although you can turn that off if you don't want it. And in this case, we typically wouldn't want to typeset the code and then immediately beneath that have the standard out. So you have to use a print PythonTeX or equivalently a standard out PythonTeX command if you want to bring in the content that was created by the block environment. There is continuity. All of the code by default, if it's in a code or in a block, executed within a single session. So I can go back, access that previous variable, change it, print it out, and get the new value. If you do want to use custom user-defined sessions, then all you have to do is just provide an optional argument, in this case, slow session, that splits off this code into its own session. It'll run separately. This would be an absolute waste of time because this code would go relatively quickly, but if you had some relatively heavy number crunching, really good option. There's a verb environment. This just typesets the code. This is just for completeness. And then finally, a console environment, which I'm very excited about. I've just added this in the last few weeks. What this does is it lets you put in a series of commands for Python, and using the code module, that's actually treated as input to an interactive interpreter, so then you get the output there at the bottom. This is good if you want to typeset sort of pseudo interactive sessions within your document. There are also commands for inline use. There is a code, a block, and a verb command. These are just equivalent to the environment, but suitable for inline use. So you can actually put highlighted source within a paragraph, say if you want to use the block command, although you can turn the highlighting off if you don't want it. There's also a special command, the py command here, that brings in a string representation of whatever object it's given. So useful if you don't want to use print. There are some other special things that you can do with that, but I can't really get into to that with the time I have here. So those are the tools, the commands and environments that PythonTeX gives you. What I'm going to do now is show you a few applications and then wrap up with a few additional examples. And the examples I'm going to show you are not going to actually use those py commands and environments. There's also a set of commands and environments that are exactly equivalent, but start with a pylab prefix. Those provide access to matplotlib and NumPy. And there's an equivalent set that has a Sympy prefix that brings in Sympy automatically. And this is just an easy way to separate content so you don't have to have explicit sessions and just keep things a little bit more organized. So with matplotlib, what you can do is just drop a block of code into your document, save the figure at the end into PDF, use include graphics, get something like this in your document, again, without ever leaving your tech editor. If you need to change the colors, if you want to work on the fonts, get those to match with the rest of your document, just go up to your code, edit that, run LaTeX, run the Python script, run LaTeX, new updated plot will be in your document. Sympy is ideal for interfacing with PythonTeX because it provides the LaTeX representation of objects. So in this example, what I'm doing is defining a symbol x, I'm defining a polynomial equation, and then I'm using this Sympy command to bring in string representations of the equation and the solution of the equation, and that automatically ties into Sympy's LaTeX printer class and returns a LaTeX representation, which I'm showing at the bottom there. So if I wanted to solve a different polynomial, I just go back to that code, edit that, immediately get the typeset result back in the document. I don't have time to get into it here, but you can actually customize some of the way that Sympy typesets things with LaTeX depending on context. So you can have it use small matrices if you're inline, and you can have it use a large matrix if you're in an actual large equation context. Another example with Sympy is step-by-step derivations. So in this case, I'm starting off by defining an equation. I'm going to do a double integral on that equation, and I'm just calculating the steps 1, 2, 3, finally putting in some LaTeX code to bring in the results and typeset that using the align environment. Get this result. And this is relatively simple. I didn't save a lot of time by using Python rather than just typing it by hand and just sort of thinking about it in my head. But as long as you can express some equation in a step-by-step form in Sympy, you can have the result then automatically generated, something like this, within your text document. Final example with Sympy. What I'm doing in this case, I'm not going to go through the great details, but I'm defining a list of strings at the beginning, and in that list I have sine, cosine, hyperbolic cosine. Then I have another list of strings with integral and derivative. I'm combining those strings to create integrals and derivatives, essentially commands as strings, using a val then to actually do something with those, automatically creating a little integral and derivative table here. And if I wanted to make this bigger, all I'd have to do is just go back to that code, and that list of strings of names of functions, if I just put additional functions into that list, I could automatically generate more of these. I actually have an example on the GitHub site where I do essentially a whole page of equations like this. So I'm sure there are a lot of other applications that all of you can think of for this, but those are some of the ones that I've been most interested in myself so far. So to wrap up, I want to mention a few of the additional features that I'd had in the list of features at the beginning. Treatment of error messages is really critical for something like this because, again, line numbers in the document versus line numbers in the executed code do not match up, so this has to be handled very carefully. So the example that I'm showing here, there's a plus with nothing following it. That's a syntax error. And when you run the PythonTeX script that processes the Python code from the document, you'll get an error message like what I'm showing here. And what you want to pay attention to here is that there's that line that begins with the asterisk, PythonTeX code error line 104. That would be giving you the line within your document where the error actually occurs. So you can just go back in your document, find line on 104. That'll be exactly where this occurred, fix things there, recompile, and you're done. Now, sometimes it might not be real convenient to do it that way if you've broken your code up between a lot of different environments. So the other thing that we have here is it's saying file, and then there'd be some temporary script name that was executed, line 47. What you can do is tell PythonTeX to save the temporary files that were actually executed, go back and look at those temporary files, and then you could look on line 47 there and also track down the error that way. So several options in terms of the debugging, but the idea is that if you're using a text editor that allows you to view the standard out from the PythonTeX script, you should be able to edit within your editor, run the script, see the standard out coming out of the PythonTeX scripts, see this error message, use that to do the debugging, and never have to actually use the, never leave the editor unless you're really doing something terribly wrong. Typically, errors are a really bad thing, but if you're dealing with a teaching context like I am, or if you're doing some documentation, you might actually want to create some errors and then typeset those. And so I've also provided a way to do that. Reusing, again, this same example with a syntax error, what we have here is the a PyBlock environment, so that's going to typeset its contents, and then the error message, I put a standard error PythonTeX command in that'll bring in the standard error. We get this for the result, so typeset code right next to the error message that it produces. And the key thing I want to point out here is that the line numbers in the error message and the line numbers in the code match up. Line 3 in the code's where the syntax error was, message says line 3 too. Now, just looking at the code here, that would seem to be relatively obvious, but the problem is that PythonTeX doesn't just run the user code, it also has to run some management code so that it knows where standard out came from, where standard error came from within the document so it can bring things back and synchronize those. So the standard error here actually has to be parsed and then lined up with the user code. Final feature that I do want to mention, again, syntax highlighting with pigments. Even if you don't want to run PythonTeX code from within your document, you can use this if you just need to typeset some code. So any language supported by pigments can be highlighted. I do also support Unicode. As far as I'm aware, this is the only solution for LaTeX that uses pigments that supports Unicode under the PDFTeX engine. And I think, let's see, there's also the listings package which will support Unicode, but you sometimes have to do some little tweaking with that to get it to work. With this, just drop the Unicode into your document. If you have your document set up to use that correctly, then you should be good to go. And this is a really bad example here, using random Unicode strings as variable names, but if you insist on bad practices like this, PythonTeX will cooperate and highlight your bad results. A little bit about the future of PythonTeX. At this point, I'm on the 3rd public beta. I need to develop some additional documentation, additional examples, additional testing. Things seem to be quite stable and quite usable, but a little bit more to be done in those areas. In terms of future development, I'm thinking about a couple of things. First of those is what I'm calling dPythonTeX. So in the current system, once you run the Python side, you can keep compiling the document without having to do anything with the Python side. And if we're thinking about more of a publishing context, some publishers might be okay with that, but having to use the PythonTeX package still could be an issue. So I'm thinking about possible ways to take a PythonTeX document and the output, merge those back into a single document that no longer requires the PythonTeX package, maybe use that to get a format that's a little bit more acceptable for publishers. The other thing I'm thinking about is that in the entire development process, I've tried to make this extremely general, so not, even though it's written in Python, not many Python-specific features, and so I think that in the future should be able to provide access to, say, Sage and maybe Lua or some other languages like that. So I'll stop there. Code, full documentation is on GitHub. Again, still in beta on this, but I think it's pretty stable and pretty usable. Thank you.
Do we have time for a couple questions?
Okay, so I really like your system, and I'd love to use it. I was just curious, did you use PythonTeX to create these slides?
Absolutely everything that you saw, except for those few figures at the beginning, was completely done within the tech editor.
Awesome.
So I actually wrote and debugged, never left.
I'd also like to reiterate or make the comment that your dPythonTeX is probably the key feature I would need to use this, because most publishers don't like to have all these extra packages. So I just like to say it's a great piece of work, and as soon as PyTeX is there, I'm all aboard. Thank you.
Thank you.
Yeah, I just want to agree that this is really cool, and I'd like to use it too. But I wanted to ask, can you access some of the LaTeX variables or information from inside these Python blocks? Something like parse skip or some of those parameters.
In terms of passing some kind of LaTeX variable into Python and then get back?
Right.
Right. So that's one of the things that I haven't put into the documentation yet, but if you do define a tech macro and use one of these macros inside of it, you can't use any special characters. If you're using one macro inside the other macro, there are some bad things that happen, but you can pass tech variables into Python, and then if you just have Python print back tech code, then you can pass things back and forth. So not yet in the documentation, but should be there in the near future once I finalize a few things with that.
Yeah, I also want to say nice job. Sorry if I missed this, but if I'm playing around in the Python block of the code, and I do need to import a can routine, like a bezel function generator or something, is that possible?
You can import anything, so everything is executed within the block and code environments. It's just written to a temporary file, executed like that, so you can do your standard import statements. I've even figured out a way to allow future imports. So you can, as long as you put the future imports at the beginning of the first block or code within a given session, you can do future imports, and that works as well.
Thanks.
All right, that wraps up this session, so let's thank Geoffrey and get